Hi, everyone. This is Marty from Schema, and I'm really excited to be talking to Amanda Gioia from HED today. Amanda, you did a really cool presentation at Built ANZ, and I just wanted to, I've been looking forward to discussing it with you for a while. So welcome.
Thanks, Marty. Thanks for having me. I'm excited to be here.
So maybe I should put up we have I guess, a background slide um, that you had at Built ANZ. with
Yeah.
your list of accomplishments, also being the first time at Built in Australia, right? So what I find so cool about your role at HED is that you are the practice technology leader. And so I wanted to ask you a little bit about that to describe what your role is at HED.
Yeah, so at HED, I'm part of a dedicated team of professionals, and we all have slightly different responsibilities, but a few of us have the title of practice technology leader, and we focus on enhancing efficiency, innovation, and quality across the firm. And we're responsible for a few key areas. So that includes all aspects related to project creation and setup. We also help support the library, the firm-wide library, and we help with developing and maintaining the style manual, sample projects, workflow improvements, and we provide technology support. We also help with project reviews, technical assessments, and we provide training that could be with software, tools, or workflows. And then we also, another one of our last key area is project delivery. And this includes things like facilitating project kickoffs, coordination efforts, and project support. And then we also have some additional support areas, which leads into some of the things that I like to specialize in. So we have some research and development efforts, and this can include a focus on innovative tools and workflows, such as data-driven design. And another one of our additional support areas is supporting reality capture technologies as well.
Cool. So you had a project to evaluate data center design tools. Now, you're not a data center designer, but you had enough expertise to take this project on. How did you get assigned this project?
Yeah, so like I said, we're a few practice technology leaders at HED, and each of us is assigned a specific market sector. And while data centers fall under mission critical sector, which isn't one of my sectors, I'm assigned housing, uh, and mixed use and workplace. I still became involved because of my expertise. So I'm an architect with a master's in advanced computation for architectural design, and I have a strong passion for integrating machine learning and generative design into architectural workflows. And so, whenever a project involves these areas of innovation, regardless of the sector, I often get pulled in to contribute. And this allows me to bring new tools and methodologies into the project, which has been a really exciting challenge for me, especially in this highly technical and fast evolving world of data center design.
Yeah. So what's driving HED to look at data center design automation?
Yeah, so HED is seeking strategies that reduce the design time while not compromising the quality of the results. Um, we're looking to find a computational design tool that can generate more iterations quickly, yet precisely, that can be analyzed for their viability. And the hope is that the results will generate solutions not conceived by the user, but to be surprised with the results the software generates.
Yeah, so back a couple of years ago when I was at Dassault Systems, I presented at Data Center World because of the use of some of the data center companies getting interested in doing manufacturing tools in data centers to try and speed things up because I guess everything in data centers is just how fast you can get them done. So what kind of time pressures are you and HED getting from data center owners and how are you responding besides just the tools?
Yeah, so even with the current process without using computational design tools, we are meeting our timelines and goals with our clients. It would just be good to have more people to be able to generate site and building designs quickly. And we hope that computational design could be that solution. If we find something that is sophisticated enough to have the parameters and the flexibility that our clients and projects demand, then we can help supplement some of the designer's time.
And so there, in the data center world, we're not going to go into what, all the data center segments are, but I know there's hyperscale because that's what we were doing back a couple of years ago at Dassault. And there's co-location and a number of other ones. What are there any that HED focuses on, or you guys do all kinds?
Yeah, we do all types of data centers, including hyperscale and colo, and the computational tools appear to be most relevant to these segments at this time.
So, and I recall, so it's interesting because a lot of what determines whether a data center is good or not is not to do with occupant comfort or any of the things that we would think of for normal architectural buildings. It's all about
Mhm.
power usage. And so there's this measure that's constantly talked about in data center design called PUE, which is power utilization effectiveness. And again, from a couple of years ago, a good PUE was like 1.8. And as equipment has gotten more and more efficient, and like PUE is a measure of how much of the actual power going into the data center is actually driving the compute. So I would imagine the ratios keep changing, and it's a fast evolving world. So just curious as to what kind of target PUEs you guys go after when you design a data center.
Yeah, so according to our data center designer, a good one is considered 1.3, and our design target is less than that.
Hmm. So just on a personal note, what kind of challenges or opportunities did this project present you with personally that you were looking forward to?
Yeah, so personally, I found that this project aligned with my passion for computational design. I'm always seeking new ways to empower designers by refining workflows that optimize the design and documentation process. In past projects I've explored, I looked at computational design tools that could optimize building massing studies based on occupancy and site parameters, as well as another example where I created workplace test fits driven by parameters like area, adjacency, and noise. And this data center exploration project is sort of an extension of that, because a lot of the same conditions overlapped, but it gave me the opportunity to apply those same principles in a much more technical field of data center design.
And so you have a master's degree, you've got a degree in AI, ML, computation. Um, how are you applying those? How much free rein do you get to experiment? How are you applying those skills in what you're doing?
Yeah, so with my master's program, I was able to bring in some of my work from that, specifically from my thesis project, where I developed a tool called Daylight, spelled Daylite. And it was designed to address some of the challenges associated with daylight analysis tools in Grasshopper, which typically require significant time and training. So I'm talking about Ladybug and Honeybee.
Mhm.
Um, and this tool leverages machine learning to make quick supervised predictions for daylight design. If you adjust various parameters like the room size, window configuration, shading, and surrounding context, this tool can rapidly predict the daylight potential, and then the results can be evaluated. And if whatever selected design you choose can be generated in 3D modeling software or a web application. And so the initial concept for the data center tool, which is obviously currently still in development, operates on a similar principle. With a given site plan and a kit of parts, users can adjust parameters like floor to floor height, number of stories, or power usage effectiveness, and many more. And then the ideal tool would output key metrics such as total area, megawatt capacity, number of buildings, and this would provide a streamlined approach to designing data centers. This was, of course, before we began engaging with software like Schema, like yourself, and the concept has evolved since then. In addition to the technical skills that I gained from my master's program, it also taught me how to present complex workflows clearly. So this helped guide the conversations throughout this project effort. So it's something that translated into the development of the concept diagram that I shared in my presentation at Built. So yeah.
And you covered a number of tools in your presentation at Built, and you did present the kit of parts, and we'll show some of that in a minute so that people can understand your presentation, because I do want to show some of it and have you talk about it. But there's probably people on here who've never heard about Schema or understand it, and so we want to discuss a little bit of that, the things that underlie Schema, because Schema is not something that was built actually to design data centers. It has a horizontal workflow that applies to lots of different types of building, and it's what I call a content-driven approach, as opposed to a computational scripting approach that you obviously have a background in. So in a way, I want to have a discussion with you about these two different strategies, and talk about them, and then show what you did with Schema compared to some of the other things that you've done that are based on a purely computational approach. So I guess first off, do you see that there are these two sort of approaches, one which is a scripting and almost code writing type approach, and the way I think about it is that you write a script that generates a graph, and that graph generates geometry, and we have a different approach where you don't write a script. You get a bunch of geometry, and we extract the graph, and then by manipulating that a different way, you get a bunch of geometry. So at the end, manipulating the graph produces geometry, but the inputs are different. What are your thoughts on just those two basic approaches?
Yeah, so I think with the approach, the scripting and computational design approach, it allows for more customization, but you have the higher entry cost of understanding the software, potentially the Revit API, Python, various, you need a lot of knowledge to get started in that, to be able to do that. And then chances are that the tool that you develop will maybe only be applicable to a handful of projects, whereas the approach of using a tool like Schema will allow you to, well, basically it will allow any beginner to be able to engage with the tool, and then it can be applied to many projects. However, there is no opportunity for customization. So if you're used to doing things a certain way, and maybe if you don't like the way the tool works, there's not really that much room for customization in the moment compared to using computational tools.
Right. And all of our customization is through content and content approaches as opposed to scripting. However,
Or workflow.
that's about to change, and we'll talk about that when we get to the roadmap. And we'll also talk about some other projects that mix the two approaches. So, because I don't actually think it's an either or. I don't think it's a content-based approach or a scripting approach. I think it's a combination of both. But I'm always really interested in making sure that like mere mortals can approach a problem, as opposed to having to have a master's from McGill just to start thinking about it. That's not to say that you can't get farther, but I think it's just philosophically we're trying to make a tool that can apply to many different things and then be extensible with the same skills, but not necessarily be bound to only those skills.
Yeah.
The other part too, and we'll show what you did with Schema in just a minute from your presentation at Built. Part of what the problem is, as I understand it from early data center design, mostly recently talking to owners and designers, is that they have to build so much data center capacity that they're even looking for situations where if they can attain a parcel of land, they want to find out whether the adjacent parcels are going to be available anytime soon, and come up with expansion strategies. And they're looking at not just one data center design, but a whole range. And so the design tool requirements are getting steeper, because this means not only do I have to look at the massing and the site, I have to look at parcel data and consider many options as far as a mix of parcels, a mix of massing, and all of the things that go into data center design, given those two inputs. What has your experience been around that, or was that part of your mandate?
So at the beginning of the initiative to look into streamlining data center designs, at first we were looking more at the design at the site level.
Mhm.
So given a site plan and kind of like organizing data centers around a site, the buildings on the site and the electrical yard and that sort of thing. But over the course of the project, the requirements changed and we started to focus more on the building itself and just the single data center building and designing that. But as a firm, we do have to design both. It was just what we wanted to target our computational design innovative workflow strategy towards. So there's two different scales that you could look at the project at.
Mhm.
And we chose to focus on it at the building level.
And so this mirrors my experience both on the Dassault side using a scripting approach and on the schema side using the content-driven approach, in that it's really like a two-step problem. The first is what I call solving the general arrangement on the site.
Mhm.
So, and this is the reason we made a generalized tool, because solving this general arrangement problem is very similar for an apartment building, a school, a hospital, or a data center. It's what drives the program. How do I arrange those? And that's based on whatever the target for the building is, whether it's occupant comfort or number of kids per classroom or number of hospital beds and patients served or PUE. That's usually some metric determined by an owner who's interested in having that facility. And then once you have that figured out, you have to figure out how the guts of the building are going to serve that. So I always, and I use this analogy, and it's a weird one, but I like it, in that a data center has racks of computers that generate heat and they require power. So you got to get power and cooling to get rid of the heat. Just like a school classroom, there are kids in there that generate heat, and you got to have cooling, and it's got lights, so you got to power them, right? So, but so from the standpoint of the topology of the problem, they're similar, even though physically they look very different. And so from a step one to step two, I think we have an interesting answer for step one, where we're figuring out the general arrangement on the site and coming up with a building. Part of what we'll discuss on our roadmap is the second part, which is it's a very electrical engineering and piping intensive problem once you have a general arrangement. And oftentimes the solution to that actually determines the PUE. And so you don't have the answer until you solve the harder part of the problem, and then you have to come back and iterate. So it's just like a loop between step one and step two. Is that what you found in looking at this with a number of tools?
So a lot of the tools were only providing architectural scope,
Mhm.
and we're an integrated practice, so that's helpful for us because we can, have electrical and mechanical and architecture all working together. So far, we haven't really found a tool that can combine those three disciplines together. That's why I think that to really get exactly what the the data center designers would truly want, it would probably be going more towards a computational scripting approach.
Mhm.
Um, but yeah, so our experience with the tools has not uh, included the engineering disciplines, unfortunately.
Okay, so this will be an interesting conversation to get to. Before we get to that part of it, which is the sort of hard part of the problem to solve,
Mhm.
I want to go over the experience you had with Schema and what you presented at Built, and so maybe show some of the slides and have you talk to them. Um, and so let's get into, first off, the campus planning and the kit of parts you use. So let me share that and just have you comment on those first. So this was so we don't have all we've sort of got the schema centric part of your presentation.
Mhm.
Um, so just a little bit for us about the campus planning, and this was the example that you used at Built. So just if you can describe the way you framed it.
Yeah, so this effort started about a year ago, where we began engaging with our mission critical sector to develop this tool. And at the beginning, it was, like I mentioned earlier, the primary objective was to generate various iterations of data center campus plan layouts on a designated site and to potentially automate the design of that site plan. And then as the discussions went a little bit further, it became crucial to identify the goals and expectations. And so we evolved more to looking at the data center at the level of the building.
Mhm. And
So this,
so part of what you do here is develop a kit of parts. And part of what Schema does is has a design catalog, which is really a bunch of assemblies that are pulled out of a BIM system that you reuse. So first off, you had this concept diagram of the things you think about when designing a data center. So maybe cover this a little bit, and then we're going to show the kit of parts.
yeah, sure. So this is one of the concept diagrams I was mentioning earlier about how I got some technical skills from my master's program, but I also got, the skills to be able to communicate concepts clearly. And this was really helpful in guiding the conversations and understanding the goals and expectations, even though they're shifting constantly. At
Yeah.
least this kind of like helps us understand what we are trying to do. And so with this, basically it demonstrates how a data center plan can be generated using a provided site plan, a kit of parts, and then some adjustable parameters, and then it would output the key metrics related to data center design. So this was after developing this concept diagram, I went on to develop a proof of concept. Um, since the goals were developed, I used tools like Dynamo to test various packing strategies like random layouts or layouts with defined spaces and offsets. I also explored some other software that we already had at HED. These explorations raised further questions and decisions that helped us to prepare when we began our engagement with AEC companies like yourself.
Hmm. Cool. So you had to come up with a kit of parts for whatever approach you were going to use, whether it was content-based like ours or script-based. And so this is, what you showed it built is the kind of kit of parts you were looking at. And, basically parts of data halls and electric yards. And so maybe get into that a little.
Yeah, so our data center designer developed this kit of parts alongside my explorations with the computational tools, because this would be a useful tool to develop regardless. And what this illustrates is the electrical yard layout guidelines and building layout guidelines that would be used either by the software or even by a user if they were going to do this manually. There's specific guidelines that they have to follow. And so this illustrates the dimensions, like the offsets that you need. Um, if it's in a certain orientation, you need this such spacing, or in another orientation, you need a certain amount of spacing. So that's what this illustrates. It also has some equipment layouts. And yeah, I think that this would be a very helpful tool regardless of what we use in the end.
Yeah. And so Schema has this design catalog capability, which is used to basically build a library of assemblies that you're going to reuse as chunks to put a building together. And it doesn't really matter what kind. What's interesting about data centers is you're not really dealing with walls so much as you're dealing with area demarcations that have equipment in them. And I know that we gave you a little bit of help putting that catalog together, but I think for the most part, it's self-serve. Can you just, what was your design catalog experience? I know Alex helped you do some of it. We'll dive in and maybe show what was the result of that so that people can understand it. Um, how
Yeah,
was your
so
experience?
the experience of working with Schema and your team had been very collaborative. Uh, they begin by organizing the workshop. I think it's like a 3-hour chunk of time where they're going to introduce you to your team to the tool using your own Revit files. So in our case, we use data center spaces to create a tailored design catalog. And then the workshop itself included an overview of Schema, some hands-on training for the members of the meeting. And at the end, we also had an opportunity to provide feedback, which was really helpful. One of the key advantages is its Schema's ability to leverage your firm's existing designs to accelerate new projects. And then I also found that the integration with Revit is seamless, and it allowed us to work directly with our content library. So I think that from my understanding, the way that a regular user, a regular client of Schema is meant to use the design catalog is that they have the ability to create their own. Is that correct?
Yeah.
Okay, so in our experience, we didn't actually create our own. We just handed the files over to your team and they generated the catalog for us. So I
Yeah,
didn't
in
get the
fact, this was
experience.
that when we first launched Schema, that was pretty much the way it all worked because we hadn't built the tool that allowed people to do it themselves. And now we have this Revit plugin that allows people to do it themselves. But let's show, just so I'm in the HED account because I'm sort of the super admin. And so here are the catalogs in the account. So we actually publish sort of demo catalogs. So if you wanted to try out making a hotel, you could just click the plus sign here under the hotel and it would add it to your tenant. But in your case, working with our team, you created this data center catalog. And so if you each one of these is a chunk that you use, and we'll show from your presentation how you combine these chunks to make a data center. But if I were to say dive into just this restroom layout, for instance, you can see that, right, it's a restroom layout. It has sinks, it has toilets, it has whatever you've got. You don't see these in Schema, but when we turn that back into native Revit data, then you get those back the way you had them in whatever project they came from. So that's sort of the magic sauce of Schema, is that it figures out how to make this back natively in Revit with any of the properties and standards you put into it without you having to write any code to figure out how to do all that stuff. So that said, let's go back to your presentation and you had talked about why you decided to try Schema, in that you could leverage your previous Revit designs, and particularly Revit because, some of our people came from the startup that made Revit. So this is one of the reasons we handle that data so cleanly. This is just, I figured I would show the process of creating catalogs. So just as a refresher for you maybe, but anybody on this call that doesn't know how this works, essentially, you have groups in a previous project. We've just made them neat and orderly, but it doesn't have to be neat and orderly. And there's a plugin in Revit that uploads them to the Schema cloud and turns them into what I just showed you as a design catalog. And in this case, we have a residential example. And if you dive into one of those, you see the residential layout. And those things are on the left when you are working in the editing environment Schema. So basically, a big chunk of, say, BIM data that represents an apartment unit or a piece of a data center, and you can just move them around like magnetic puzzle pieces. And this other ability to change the layout using a capability we have called morphing. That's the main thing about the design catalog and how it's used in Schema. For the data center, this is from what you said it built. This is how you summarize the benefits, and I really liked this because that means we must be saying something right if you put it on a slide and tell a bunch of people. So seems like you had the flexibility you needed and quickly got to something at least.
Yeah, we definitely did. I mean, we were still using it at the level of just testing, but we had an internal after the workshop, we organized an internal testing session between some HED data center designers,
Mhm.
and they shared valuable insights into their experience. Some of them admittedly struggled with the learning curve, but there was a clear acknowledgement that Schema has potential to streamline data center design once users become familiar with it. So
Awesome.
it seems promising in that regard.
So just, what you did that you then showed it built, basically put together this schematic layout for a data center, and then did the old push it to Revit, and then it looked like this, right? So these were the chunks that were in the catalog. You made a new general arrangement for a new data center on a new site, and then when you pushed it to Revit, you got this output from it.
Yeah, it's amazing how fast that transition from Schema to Revit is, and also the fact that it uses the original families that you initially fed it is amazing as well. In our example, since it was just like workshop test, we didn't really use all of our standard families, but it would have been nice to see a project where we could have actually seen standard HED families used as the output because the result is pretty impressive.
Yeah, and this is, I think, one of the big things that separates us. Having worked at a lot of different companies that have done 3D modeling software, when a company tries to get into the AC market now, whether this is a web app that's coming out now, or good old 20-year-old BIM or modeling software, the typical approach is, oh, I have a data model in IFC. I'll write something that can speak IFC, and then Revit can read in IFC. But the problem with that is you lose a lot of data, right? Because any properties that you add on the Revit families, IFC is always the lowest common denominator. So whenever you use a data mapping approach like that, you're always not going to get back what you put in. It's just the way that it works. And this is one of the ways that we're really, really different in that when we make the catalog, we pull the native Revit data as a binary blob and store it. And then when we push it back to Revit, the whole thing is there, right? With your all of any changes that you made to the families and all the naming and all the special shared parameters or whatever you added to it is all still there because of the way that we do it. And to my knowledge, we're really the only ones that do it this way, going native in and native out. Now we do IFC for other situations, and we're going to talk a lot about that when we get into some of the SketchUp work that we've done over the last 2 months, which is for a totally different session. But that's part of why that works so well. And for us, we've been told that rather than moving from concept design into this detailed design that we see here in Revit and having a team of several people take 6, 7, 8 weeks to do that, you were saying you were surprised at how fast it was. It's like 45 seconds or a minute, right?
Yeah, the integration is very fast. I also appreciated how organized it was, like the way it put context on a link, and the rooms were preserved as groups.
Yeah.
Um, it's nice not to just get a whole mess of content in that
Yeah.
transition. So the organization is appreciated as well.
Awesome. So basically, you also then at Built shared kind of the brief that you came up with to do this testing, sort of a test site, and then some goals as to the number of stories, what equipment, and the program for the data center. And then walk through with some examples. You showed sort of a picture of the catalog that I just showed in the Schema product, and then getting into using that catalog. I think mainly we'll show a little bit about how this works because you went through the whole workflow. I won't go and maybe play all the videos that you played, but just how a site is created in Schema and then how you can create the massing for a new project. So literally just put in an address, trace out where the site is, and then we use OpenStreetMap data to create the 3D context for whatever the new project is. What's going to be really interesting, as I mentioned, some of the work that we're doing with SketchUp is that Trimble, the owner of SketchUp, is originally a GPS and mapping company. So they have all the same sort of mapping, right, that other mapping companies have. So the ability to get to sort of really accurate parcel data and mapping at the beginning of the project is a really interesting possibility for us as we move forward in some of this stuff, especially at this phase where you're defining the site and you're looking at the various parcels around the plot that you're looking at. At this point, I'll move forward and we can talk a little bit about how the massing is done. This is mainly you showing how you use the tools in Schema, very similar to what is done in SketchUp, where you add edges and you push pull and make changes. So as far as this part, was it pretty easy to pick up?
Yeah, I mean, you have that little blue question mark in the bottom right of the screen, and I feel like just following a few of those video tutorials can get you most of the way there. Um, and so I was just trying to show what I was trying to demonstrate here is how easy it is to use the tool for the
Mhm.
modeling and 3D modeling and mass editing capabilities.
Awesome. And then,
And
of course, we have some built-in analysis. So you don't want a lot of solar gain in a data center. So siting is important. So we just showed, the sunlight calculation and daylight, various forms of daylight calculation.
yeah, and I appreciate this tool. I understand that this is a integration with Cove tool. I'm curious to know if there's going to be more environmental analyses coming into the product in the future.
Yeah, so just this daylight is an integration with Cove Tool. The other ones are our own.
Oh, okay.
Um, Part of this, when we get to the roadmap discussion, is going to be around the integrations that we have with the Rhino compute stack and being able to run things like Grasshopper and Ladybug inside of Schema. So that is fairly short term on the horizon for us. And that will, of course, give us the ability to do that sort of thing. Another thing we point
Fantastic.
out is as you develop the project, the ability to go and look at the analytics, and anytime you make changes, they're all there in the key figures, and the ability to generate your own reports, things like that.
Yeah, I love the customization of the key figures, the different pivot tables and all the different fields that you could add and like make your own key figures. It's really powerful for anyone who's interested in tracking the metrics.
Awesome. So part of what we're going to do with this, and so now we're going to show, exporting the data center to Revit, so that you could see what it was like using the Revit plugin to pull it in. So then this is that data center that we were showing in its final Revit native form. Um,
Yeah, so those are all the organized groups and the link that I mentioned earlier and has a organized file structure.
Very cool.
Hmm.
So, this catalog creation and how you reuse chunks of previous projects is pretty important. We're putting together a new video on using that, so because there's lots of people interested in understanding how to do that. And part of what we're planning to do is hold some more training for designers and BIM managers and other BIM coordinators that are going to be using that a lot. So by the time this gets put up, we'll probably have something like that under the Schema Knowledge Center. So if you're watching this and you want to know more specifically about the catalog creation and how you reuse all the Revit assemblies, take a look in the Knowledge Center. Okay, so it seems like you were able pretty, without too much onboarding to get a result where you were able to come up with 50, 60% of what you needed to do. Obviously, then there's all the engineering side of this for the electrical and the piping.
Hmm.
But what we always say is we're not trying to do 100% of a building. We're trying to be the fastest way to get 50 or 60% done. Um, did that kind of match your experience? Were you able to sort of quickly get to something workable so that you could then explore the options around that?
Yeah, I mean, there's a lot of there's a lot that goes into adopting a new tool. I think for testing purposes, I was able to get the workflow out of Schema that I intended. However, it really surprised me that there was some initial hesitation from the data centers team to adopt the tool.
Mhm.
I expected more enthusiasm given the potential for Schema to streamline the design process. But what that really did is it just highlighted that even when a tool is highly innovative, there can be barriers to adoption that go beyond the technology itself, such as workflow integration or familiarity with new
Yeah,
approaches, for example. So I would say that the tool worked as expected. However, it's not, it's different from the current workflows. And so that poses some hesitation to
right.
adoption.
One of the things that we find overcomes that is when people see the Revit data. When they see that it's what they're used to, then that sort of helps to overcome that barrier. But yeah, you're right. I mean, um, that's something you run into anytime you have any sort of thing that affects the design process, because designers are always very protective of their process, and they should be.
Yeah, and I mentioned this, and so this was a big part of my presentation at Built, and I feel like it was very well received from the other practice technology people that were attending the conference. I think it's a problem that that we all struggle with collectively in the industry. So it's not surprising from that in that regard.
So I want to shift gears away from just what we did with Schema and talk a bit about what's coming in data center design. And it's the timing here is interesting because last week I was I'm every twice a year I meet with a group of CEOs of electrical subcontracting companies, and it's always really interesting to find out the heartbeat of what's going on with the guys who actually install stuff.
Hmm.
And a lot of them, because when you look at data centers, it's such a big piece of electrical scope. You have these electrical contractors that are, you know, commercial in nature, and so they could be doing apartment buildings or schools or data centers. And for them, in some cases, they're deciding that because the data center is almost all piping and electrical work and very little architectural work, that they, you know, a big subcontractor could turn themselves into a specialty contractor working with a mechanical subcontractor and basically a guy who puts up, uh, for lack of a better term, a warehouse to make a data center. Um, and so I think it's pretty interesting because uh, I could almost see a situation that for building type, and this has already happened in some simpler buildings, like say precast parking garages, where you get turnkey solutions from a company that specializes those. That said, parking garages don't have much equipment and don't have any interiors, so they're very, very simple. Data centers are way more complicated than that, but I could see definitely a situation where you might have joint ventures between design companies and specialty contractors specializing in data centers that are offering turnkey solutions. And with something like Schema that could aid the data flow between the two. So we definitely have this vision of evolving a design rapidly from LOD 200 to 300 to 400 in Schema, and then using the interfaces we have to push that design to various places. LOD 400 being what the subcontractors need to actually purchase and install. Um, I wanted to get your read on that idea, whether you find yourself, and you mentioned the engineering in-house. How are you working with the engineering teams? And um, I guess this is almost a CA conversation around construction administration when it goes into construction, but on the latter end of the process, dealing with the engineering side of this and the construction side of this, what are your thoughts on, given the time pressures, how this might evolve?
So this is one of those places where I unfortunately don't have much experience
Yeah.
because all of my experience working as an architect was in housing and workplace and a little bit of education and healthcare. But I did not have any actual experience as an architect with data centers, so I never went through the CA process as a data center designer. So I unfortunately can't really speak to that for that market sector.
So one of the things I wanted to point to is, so before I move on to the MEP stuff, you did have some uh, pros and cons. Um, a number of pros, cons not being tailored for data center design, but part of this is the MEP capability that we were discussing, um, and uh, getting into tailoring things for data center design. I wanted to discuss a bit of the work that we're doing with SketchUp, primarily for the idea of using Ruby apps and Ruby scripting to do some of the equivalent things that are done in, say, Grasshopper and Dynamo. Um, we did an example for how, because earlier in this call, we described it as two phases where you do the general arrangement, you generate the Revit model, and then you do the engineering to support whatever you've laid out in the general arrangement. So what you showed in the Revit model would be the thing that you then have to wire and pipe. And as I was discussing the school before, we did an example in London in June where we did a school project. This is an actual project in Massachusetts. And we did a design of it just to show this and the integration and how generative AI can produce not just the architectural scope, but the engineering scope, or rather, engineers will be using AI tools to speed that process up. We ended up doing a schema design for that school where we got to the completed design, and much like what you had for the data center, this is a school, right? With the kids to cool and the lighting to provide electricity to. But here, the key figures aren't for an apartment building or a data center, they're for a school. So it's all going to be, types of classrooms and what type of space. But the interesting part about this, and the reason I want to get you to comment on it, is that what we then showed is how this can drive a whole ecosystem of apps that solve not just the problems inside Schema, but the problem of delivering the project. So in this case, what we did was we generated a Revit model for the school, just like you did for the data center. And in that model was all the classrooms with their terminal devices. So diffusers for chilled air, lighting fixtures, power, all that stuff, and ceilings, right? So we know where the plenum space is. So now what do you need for AI to help do some of the engineering of the systems? Well, first you need structure. So we ended up generating structure for this in a way that, so this is just something so that we could have a frame that would be reasonably sized. So when we did work on MEP routing, we would not go where a beam would probably be because we needed a placeholder for that beam. So we did that so that we could then work with a company to generate piping in order to get to some prefab strategies like these racks or skids. And so I won't get into what Augmenta does, but they're one of the partners that was part of this exercise. And what they did was they took our model and came up with some strategies for knowing where the equipment rooms were and where not to route, and then produced in this case, electrical conduit model that had all of the conduit and hangers and all of the stuff that a subcontractor would need to install. And so part of the reason I bring this up is that what we have in the catalog is the architectural scope. What we don't yet have are things in Revit that are part of engineered systems that have their own analytic model. So structures like that, it's a bunch of connected beams and there's a structural analytic model under it. And all piping systems, whether it's chilled water or even ductwork, they all are parts of a system, and all of the families have connectors that connect together, and they know that it's a connected system. So one of the things that's big in our scope for our roadmap is that one of our investors is an MEP engineering company. And so one of the things that we're looking at is how do we take Revit families that are part of piping systems or structural systems or duct systems and put those into chunks of the building that are then reused in order to produce a new building. So I won't say that we have the answer yet, but that's part of the scope that we're looking at in the roadmap, and that's probably something that you're going to be able to provide some input on with the data center design process.
Well, let me tell you, this is really exciting to see what you're showing on your slides now. I would love to get more details on this workflow that you're sharing. I'm very pleased to see that progress is being made. Let me ask you, what other new features can we expect from Schema's development roadmap, and what's your timeline?
Yeah, so right now we're actively working on the 2025 roadmap. So we had a roadmap through the second half of 2024. And then we got this opportunity to work with Trimble, and we essentially moved a whole lot of projects around to redirect the entire R&D team to turning Schema into a SketchUp extension, which we have not announced yet, but by the time this is up, we will have announced it, and we'll be showing it at their event in Las Vegas. That is very interesting to me in that the way that that works is that you can essentially take something in the Schema design catalog, like that restroom arrangement in the HED catalog, or a data center hall, or an apartment unit, and use a SketchUp component as a proxy for it, which means you could take Ruby code and write an entire configurator that would lay those things out, and then essentially Schema would turn those into native Revit, right? Or back into native SketchUp. So there's some really interesting opportunities that data management allows us to do. I think the other big things on our roadmap is I mentioned implementing Rhino Compute, and then there's also implementing Speckle. So we're working on both of those projects. We don't want to write our own model federation and version control. So we're working on taking what we do as a data platform and version controlling it in the Speckleverse, so that we can leverage that, because there are a lot of people that are connecting to that. And then the other part is just Rhino compute. So one of the things that we cover when we're going to show the SketchUp integration is back and flow workflow between Schema, where the layout of the floor plan is done in Schema because the block and stack is so fast, but people want to do the facade design. We had a customer do the facade design for a project where they did the block and stack in Schema. They did the facade design in SketchUp. And so we have workflows where we combine design in one tool with design in our tool and unify the data and then push it all to Revit. So there's some really interesting workflows that we have that are totally new, where you don't have to do any file wrangling and you don't have any data loss issues. And that's really attractive to anybody in design, because you've been doing a lot of file wrangling for the last 20 years. And I think part of what we're looking at is when we do the facade design and people want, say, to run Grasshopper scripts that do facade design, or they have some of those scripts, how can we take geometry that's in a schema model and publish it as things that can drive Grasshopper scripts? And how can we take geometry created by Grasshopper scripts or Dynamo scripts and pull them back into Schema? Because we can round trip data with Revit. So there's a lot of interesting opportunities now. We've sort of pioneered the content driven side of the workflow, and there's plenty of history on the script driven side of the workflow. And so now I think for us in the roadmap, we'll start seeing the first signs of it in this last quarter of 2024. But 2025 is going to be a real showcase for us to integrate these two approaches: the script-based approach to design automation and the content-based approach to design automation, and put them together, which I think is going to be really unique.
Yeah, that's exciting. I appreciate that you're addressing the fact that, Revit is a powerful tool for documentation, but people are more comfortable in tools like maybe Rhino or Grasshopper or SketchUp style of modeling. And so you're facilitating that integration more, which is, I think, something that we need as designers.
Awesome. Well,
Yeah,
we'll definitely keep you in the loop so that you can kick it and tell us what's wrong with it, and that we can keep making it better and better. Well,
thanks.
thanks so much for taking the time to have this call with us and sharing your experience. And your presentation at Built was amazing. I actually sort of found out about it right before it happened and just asked you for a copy of the slides, and then said, "Oh, we have to show people what she did with this." Any additional thoughts or lessons learned before we close this up?
Uh, I mean, no, I would just say that the experience of working with Schema has been great, and I'm really looking forward to seeing your new developments and continuing to test Schema for any market sector, really, to see if we can help streamline our design process at HED.
Well, thanks. And for anyone listening, I'll encourage you to try out a project. If you want to really kick the tires on Schema, it's best to just have something in mind and reach out to us in the help system using that little blue question mark that Amanda was talking about. We're happy to help here, and we love to engage with people trying to apply this on projects and make you successful. You can go to our website for more detail about Amanda's project. By the time this airs, we will have a case study up there. And follow us on LinkedIn to stay up to date on everything going on with Schema. Thanks again, Amanda.
Thank you.